candidate in computer science and engineering from Michigan State University, and is going to talk about the interaction between two concepts in machine learning, which is robustness and fairness. Please welcome Hanju.
Hi, my name's Han. I'm from Michigan State University, and I think we in academia and for general machine learning models, we are very care about those trustworthy issues about machine learning. They include robustness, fairness, and privacy, and so on. So for our studies, we are looking to study the connection between each others instead of just taking them as the separate things. So for example, in adversarial robustness, we study this kind of problems that we desire our machine learning model to give a reliable prediction outcome, especially when it is applied in safety critical tasks. One of the most classic example is in this image classification task. For example, we have a very well-trained image classifier, and we assume that there always can be an attacker. They just add this kind of unnoticeable perturbation. Once it is added to the original image, the model can make a totally wrong prediction outcome. So we call this kind of perturbations adversarial examples. And based on the idea of adversarial example, they can really bring real concerns to human society. For example, someone can just attach this kind of white tapes on the stop signs just in order to mislead the recognition of autonomous vehicles. And similarly, they can also ask some people to wear this adversarial t-shirt just in order to evade the detection of human detectors. And for machine learning fairness, we desire our model can equally treat different individuals or different groups from the human population. For example, someone have just found that for the face recognition models, which are provided by many very famous agencies, actually they have a very obvious disparity in terms of the recognition performance among different demographic groups. Okay, so I think until now, in terms of general machine learning studies, towards to each single aspect of these issues, there are already many very well-established methods. For example, we can use adversarial training to improve the adversarial robustness of our models. However, the question is that what if we use one method, for example, adversarial training, to improve our model robustness? Well, we just unintentionally change the fairness of our model. For example, if we are aware of the answer of this question, we may have a better chance to develop more advanced models, especially under the scenario that both of these two aspects are desired. For example, in the face detection tasks, we desire our model to be robust against different kind of perturbations, but we also desire our model can equally treat different people and different groups in the human population. So here are some research outcomes that we have developed, and we indeed show that there are very close connection between each other. For example, we studied one of the most successful method called adversarial training to improve the model robustness. Actually, the algorithm is simple. You just find the adversarial examples and use those adversarial examples to train the model. However, we find that this algorithm can actually cause very obvious disparity issue. For example, we studied the algorithm in a very simple image classification dataset called CIFAR10, and we compare adversarial training with the traditional training without training with adversarial examples. And we can actually find that actually the adversarial training model actually can have a very obvious disparity. in terms of the accuracy and the robustness among different classes in this Spartan dataset. So it means that during adversarial training, we can improve the robustness only for several classes, but there are still some classes where the model is very inaccurate or very non-robust. And if this is really the case in real application, there can really bring some real concerns. For example, we can imagine that our traffic sign recognizer can overall be very accurate and robust, but maybe there are only some traffic signs where the model is very inaccurate and very vulnerable to this kind of perturbations. We can still not say our autonomous vehicles is safe enough. And if the similar disparities also happen among different groups in the human population, it may also raise several social and ethical issues. And another study that we have done is that we actually find some fair classification algorithms also have many safety concerns. For example, we studied this kind of fair classification algorithms. It tries to enforce our machine learning models can provide an equalized prediction quality among different groups. However, the problem of this kind of algorithm is that because these algorithms are quite closely related to the human society, so the training data set can just be provided by the humans. For example, the training samples can just be the patient's health history, which are provided by the patients. Or in some financial analysis, the data samples can just be provided by the users. So as a result, maybe based on some privacy concern, those users will not provide the real information about themselves. And a more dangerous case is that maybe there are some malicious attackers. They are going to insert this kind of malicious information into the training dataset just in order to make your trained model to have a very bad performance. So in our study, we have also demonstrated that this kind of fair classification algorithms are actually indeed more vulnerable against this kind of poisoning attack. So until now, I think I have showed that actually when we are studying this kind of trustworthy issues, we may see that when we are trying to enhance one, and we may just sacrifice another one. However, in the end, I want to show some examples that based on those, for example, attack algorithms, maybe we can also get some benefits from by properly utilizing those algorithms. For example, we study the privacy issues in those generative models, like diffusion models or DALI2, which is based on diffusion models. These kind of models can generate very high quality images, just like human face. However, many of these kind of models are actually trained on a dataset which is collected from the public resources. So it just raised the concern that when we are upload our images or our pictures into the internet, maybe we have this kind of concern that someone use our face to generate images, but in a crime scene, and it will just raise a lot of concerns. And a similar example is about copyright or portraiture right infringement. For example, here is a recently very popular case is that this singer called Stephanie's son, many people just using her images to train and generate videos with her face and with her voice, but singing other people's songs, and it will just offend the portraiture right of her. So in order to protect this kind of privacy against those generative models, so our work's strategy is that we try to add these kind of perturbations based on the idea of poisoning attacks. We try to perturb our users' data, and just in order to make the trained model can have a bad performance. which means that the model cannot effectively generate the images which include our personal information. And another idea is similar. We try to add these kind of perturbations just in order to make the generated images have the watermarks, which can be detected by some detectors. So at last, I want to acknowledge that our lab from Michigan State University have many related studies about trustworthy AI, and that is the end of my talk. Thanks.
Thank you so much. And do we have questions from the audience? Okay, we have one here.
Yeah, I'm just curious if you introduce like a watermark into your images,
Yeah.
and that then could be detected if it was used by an AI program.
What?
If you introduce a watermark into your image,
Uh-huh.
and then an AI program uses a training set, could you
Yeah.
then go and find those generated images with that watermark appear? Would you be able to find that? I was just curious.
Yeah, we just try to design some specific watermarks to make those generative, based on the property of those generative models, to design some specific watermarks. So we try to make those watermarks be detectable by the detectors.
Okay, that's pretty much what I was trying to get.
Yeah.
Any questions?
Would that only work if the image that was generated used like a large portion of the original image that it's based off of? Or is it like it can detect it kind of regardless?
I think the problem is that for the generative model itself, if it don't have enough data samples for you, it cannot well generate the images with your information. So we assume that the user have a lot of samples and images, and they also insert the watermarks for each of them.
Thank you so much.
Yep.
We're going to move on to another round of applause for Nancy. We're going to move on to the next presenter, Assistant Professor of Practice in Urban Technology, Lisa Ngan. She's going to talk about the possibility or impossibility of designing ethical systems. Welcome, Lisa.
Oh, too many buttons. It's fine. Okay, so hi everyone. My name is Elisa. This is going to be a little bit of a different presentation. I'm a designer and professor of practice in urban tech, and I'll be presenting a speculative sandbox for ethical decision making. I'm transdisciplinary, and I'm assuming this room doesn't have very many designers, so I'll do a little bit of introduction on design before getting into the research backing the speculative prototype. Hopefully you'll find it refreshing and not confusing. So designers are trained to determine what ought to be, which is intrinsically a question of ethics as much as it is of aesthetics and function. If designers decide to engage in the ethics, which they may not, they often position themselves outside of time in areas of design fiction and speculative design because these are improbable time horizons, and they remove the immediate constraints of feasibility and viability, challenging the reality of their visions. In these cases, designers use design methods to solve design problems. I take an alternative approach rooted in design engineering, a branch off of design, which uses technical methods to resolve design problems and produce design research. It is not new and has a long history of its own, but it's important to differentiate because AI is not an issue of the future, but an issue of the present. As designers, we are both users and creators of tools. Depending on which of those hats we are wearing, we think of AI in different ways. When we are users, we think of ethical and trustworthy AI in the context of creativity and copyright. We are thinking about what to do about it taking our assets, whether it's going to take our jobs, and or whether it can do our jobs better than us. When we are creating tools, we are thinking of how to use its capabilities to design better ways of living and working. Whether it is better AI is the ethical judgment that requires a human-machine trust. Like every designer, I would like to reframe the question of creating ethical and trustworthy AI into a question of designing tools that can create ethical and trustworthy AI. If designers could apply their expertise to design a tool that designs AI, what would it be? This question is a slight and subtle reframing, but it leads not to the creation of technologies and techniques that improve AI, but the creation of technologies that improve design, a task which itself mediates between human and human purpose and precedes the development of AI to capture the context that generates the questions of ethics and trust in the first place. Understanding how I landed here requires us to understand the state of design in practice. To lend some color and give an introduction at once, I will give some professional background. So most of my research is about design practice, particularly around how data can be used as a design material in ways that goes beyond a statistical and analytical framing. In order to explore this, I've had experience in a wide array of design contexts, and maybe this is actually my deep commitment issues when it comes to my own career. Right now, I'm an experienced designer at Certain Measures, a design technology studio that produces both art installation and bespoke software products. Shown here is our project Mind the Scrap, which constructs a geometric form out of building waste. In the center of the software we developed to scan, classify, and analyze scrap pieces that were then reconstructed into a small prototype you see on the left. On the right is a larger prototype constructed using the same software to demonstrate scalability. Our office oscillates between constructing narratives on design-enabled futures and constructing software to bring those narrativized futures into building, software that we sell to actual clients. Prior to Certain Measures, I was not an artist. I worked in architecture and enterprise software, which is almost the opposite. On the right is the last thing I worked on. What you see is an image of the spindle assembly line for CNC machines. Each person is an operator assembling a spindle. The assembly at their station is directed and controlled through a headed gateway that displays a set of work instructions. I designed a system of data configuration that enabled those stations to be set up, configured, and managed at scale. In the middle of the generic data center with their dystopic rows of servers is the physical manifestation of the metaphorical cloud upon which my team and I built what is called a customer data platform, very useful for marketing and advertising technology. It was the first product I ever shipped, and we did it in the midst of GDPR. We couldn't figure out how to describe it at the time, but basically it allowed design engineers to develop automated workflows for processing cross-device customer data. We were eventually bought by ARM Holdings to be their device-to-data strategy platform. But this customer data platform could enable what you see on the left to be the fan experience of every sport owner's dreams. Instead, what you actually see there is the San Jose Earthquakes Avaya Stadium, one of the first architecture projects I worked on. Our clients wanted stadiums to be like Disneyland, which is what sent me in pursuit of data in the first place, first through customer data and then through network devices. Why do I explain this? Now I'm here at Taubman, back in the School of Architecture and Urban Planning, to design and teach the studio centered around data and urban technology. We focus on data literacy, particularly around AI, and designing new methods in order to help designers interact more instrumentally with data. Training students to both design and code to improve the quality of civic life, the Urban Technology program retrieves a thread of architecture history that has centered around the role of the digital in design. Today, the notion of the digital in the context of AI seems like it's from a long ago era. Nonetheless, turning to this point in history is instructive to know when creating AI-driven technology because architecture, too, has often pursued creative innovation at risk of failures with ethical consequences. Architecture always has an enemy, gravity. A dangerous building is one that does not support its own weight. As the safety requirements of a building mirror that of medical devices, we can turn to architecture as an example of where innovation and ethics can be at odds. On the left, you see Danish architect Jorn Utzon competition drawing illustrating the iconic parabolic shells that would be his global signature. The architecture and engineering team was committed to the look, but no one knew how the shells could be constructed. In the center, you can see a small model of the roof undergoing stress distribution testing, but for a full-scale building, the shells required a structural analysis that was only possible using the latest aerospace engineering software at the time called CATIA. This makes the Sydney Opera House the first building to utilize computation for construction. We see on the right that the building stood and continues to stand without collapsing and killing anyone, and there were no dire ethical consequences. We can therefore trust it. But this was only after it was 10 years past schedule and 1,347% over budget. If it started leaking or had a full-blown collapse, we would also know eventually. With AI, how do we know? Would all of us know? But returning to my earlier questions around creating technology to manage design instead of creating technology that manages AI, what is the CATIA that will enable our artificial intelligence to be trusted? CATIA is a parametric modeling tool developed by Dassault Systems. Parametric building information models are now industry standards for large projects such as stadiums. Like in the case of the Sydney Opera House, simulations can be run on parametric models for analyses evaluating the viability of construction. At the same time, these models are also critical to operationalizing the construction itself. By having a parametric model, 2D drawings are generated from families of 3D components such as columns and seats. Editing the location of 3D components updates the drawing so that a view of the model could be accurately reproduced everywhere as a drawing without dimensions and details becoming undistinct. Given that a drawing set acts as an instruction manual for construction workers and can run hundreds of pages, the integrity of the information is critical to the quality and construction of the architecture. There are no silent failures in architecture, and the industry has evolved their tools accordingly. If the shift from static drawings to parametric drawings was a shift that allowed information to stay in sync so that design could be constructed without failure, today's most ambitious design are harder to sync than ever. I will briefly describe how more data means a greater need for syncing in order for innovation to occur and the ethical consequences to be mitigated. The first major shift is the shift from singular hardware to network devices. These devices enable fully connected and responsive environments, but designing these environments are methodological challenges for designers. The technical complexity that creates a barrier to design is not centered around the number of devices, 100 drones of the same type, as much as the heterogeneity of devices, 100 different types of robots. Without control over the number of the type of devices that can be orchestrated, both the novelty and fidelity of the experience that can be prototyped is degraded. As it becomes hard to design and innovate on the novel experiences that IoT and AI-driven AR promises, it also becomes hard to assess the space of ethical consequences resulting from that design. Examples of fully immersive AR experiences we see today are mostly made possible through the capital investment of large conglomerates like Disney, whose value hinges on the creation of original experiences. Without this kind of support, novel IoT-enabled data-driven social experiences are challenging to prototype. Disney experiences in particular are highly controlled and tightly orchestrated, with the guests themselves constantly being pushed to perform in certain ways. As we consider the challenges of deploying AI in the streets with autonomous vehicles, thinking about the kind of information that needs to be synced for use within an organization at critical moments so that we can understand its design holistically will be critical to its ethical deployment. Oh, sorry, that was the wrong side. Okay. If IoT design drives the technical complexity, increasing data literacy, not AI literacy, drives the social opportunity. What we once considered computational is now mature enough in the market to be broken up into two clear abstractions, computation and data. The differentiation of data from computation and the foregrounding of tables in some of the most successful personal information management systems in the past 3 years, Airtable, Notion, Webflow, etc., illustrates a growing literacy and creative flourishing around data and its uses. However, beyond a simple personal use case, databases within organizations are often inaccessible to designers who oftentimes don't know how to query it, much less use it to create data-driven experiences. With the exception of companies like TikTok, the development of machine learning models sit outside of the design team and design processes. The inaccessibility of databases to the larger non-technical team creates questions around the problems of whether something has ethical consequences can be proactively understood if only one stakeholder type, an engineer, is able to read the information. If consequences cannot be understood by a diversity of stakeholders at the point in which AI technology is designed, then it followed that design cannot be developed that would mitigate and eliminate those risks. Given that many of the most egregious biases are historical biases latent in machine learning models, it seems inappropriate for engineers and data scientists to be the only people who can peek under the hood to perform a culture check, when we understand that it's a diversity of stakeholders who are able to perceive the broadest range of potential ethical harms. Ethical harms which may shift over time as social values change. Okay, I will skip through this. This is an open-ended talk, though I wasn't sure my audience was. But here's a model of a, let's say, Series B startups. Basically, this is a very agile environment. And if agile describes the philosophy behind software engineering, it has been co-opted as a way of running an entire venture-backed business, is meaning morphing to become synonymous with lean thinking culture, and the short-term quantitative practices espoused as a learning organization. Studies into ethical failures have surfaced a basic intuition we have around capitalism. When employees are asked why companies fail on ethics, rather than cite technical gaps, they cite a pressure to deliver and a lack of time. Within the process of agile development itself, collaboration between product design and engineering is critical. However, there are organizational silos and human silos that oftentimes slows down the work and introduce biases, whether that is barriers to collaboration because each individual, such as a product manager, an engineer, or designer, uses different methods, which leads to less problem spotting and solving. There are also heterogeneous processes such as JIRA, which lead to hybrid procedures within teams themselves. Not to mention quality management processes if the company even has them. Especially as we get into medical devices and see AI being integrated into products, those products themselves also have to be able to handle and create new processes to manage these new and changed regulations. This compounds the pressure to deliver and the lack of time. Claiming that regulation is a solution misses the human motive to try and skirt them. We have the case of Volkswagen and their shirking of emission standards as an example of when regulations failed. At the end of the day, culture is as critical as compliance. Meanwhile, what it means to be ethical is instantiated across individual organizations and institutions, all evolving at different rates, with legal regulations being the hardest one to change once it's enacted. So basically this thing, which I probably won't have a lot of time to introduce, is trying to manage the rate of change from regulations which move slower to hardware to software to data. And it tries to do this within a hypothetical, agile developing startup. Should I go through this? I'm just gonna.
We have a minute. One more minute.
Okay, sorry. So basically the way it does this is through the creation of an ethical protocol, which then gets inserted into a typical product development process. The goal here is that we didn't want any more guidelines or frameworks, and we wanted to introduce the ethical or risk mitigation strategies within the product development process itself, using a boundary object called the data model that would be shared and understood by the collaborative team. The ethical protocol is basically managing the references that exist out in the world, such as civil code and the person's or the hypothetical organization's product. And what these things represent is usually when we think of the product, we think of the data model, which includes the data warehouse, as well as the transactional data model that's creating that ecosystem for them. Then on the reference side, we pull in regulations, academic literature, and media articles. All of these are synced through this protocol. And that protocol serves as the requirements that could potentially be generated from the bottom up by the product team, and as well as passed down from regulators into the product team as requirements. So for example, in the case that I used, it's a MOOC company, so FERPA would be one that would be relevant to a company like Coursera or edX. And this protocol basically binds the data element that's living in the data model to the operative legalese that is living in the civil code. You can also look at other document types and assess sort of values and whatnot hypothetically. So, yeah, if you want to visit the website, I can. Is what is tech, what is good.tech.
All right. Thank you so much. Thanks for your presentation. Unfortunately, we don't have time for questions, so we're moving to the next presentation. Thank you so much. So I welcome the last lightning talk presenter, Cameron McCulloch, PhD student in philosophy. He's going to talk about the possibility of imposing privacy right constraints in machine learning. So welcome, Cameron.
Great, thank you. So your microphone and your slide advance. Right. Right. Yeah. Okay. Cool.
Thank you, everybody. I'm really sorry I wasn't able to be here for the earlier talks. I was supposed to be in here last night, but I missed a flight was canceled from DC, and so I had to get up at 4 this morning to get a non-direct series of flights. So I'm sad to have missed everything. This is not my wheelhouse, and I'm going to start my timer. So this is not part of my research or my dissertation. I'm in the philosophy department here. This is sort of an exploratory talk that I have not given before. And basically, there's this principle that seems to have some kind of theoretical appeal and practical appeal, but it yields some very unhappy it requires that we accept kind of consequences that we probably don't want to. So here's the principle, and I'll explain how this connects to machine learning and invite your feedback later. So if an agent obtains some information legitimately, so this could be an individual or a company or whatever, then that agent can make any inference she wants based on the information without violating anyone's privacy. So I have a really strong sense that this principle cannot be right, and for some reasons that I'll explain. So some of you might be familiar with Robert Nozick. He's a famous philosopher who died relatively young, but he wrote this book, Anarchy, State, and Utopia, which is sort of a founding, well, not exactly a founding, but a very influential, really robust defense of libertarianism. That's not going to be a super important part here. But he has this very famous entitlement theory for the distribution of material goods, which he says if a distribution is just if it arises from another just distribution and only by legitimate means. So the legitimate means of moving from one distribution to another are specified by a principle of justice in transfer. Whatever arises from a just situation by just steps is in itself just. So the idea here is, look, if you look out and see grave inequality and all this other stuff, you cannot tell anything about whether it's just or not. You have to know how it came about. And if it started from a just initial distribution and evolved through just principles of transfer of goods, then even if it ended up at some horrible place, it's nevertheless just. Now, lots of people disagree with this, but that's the idea. So the inference principle is kind of like an epistemic like a information-based correlate of this, which says, look, if I gather some information, if you tell me some information about you, and then I don't gather more exogenous information, I just sort of operate my mind on the information you've given me and try to draw inferences about that, even inferences you might not have foreseen that I could have come to by this little bits of information you gave me, I can't run afoul of your privacy rights by having gathered this kind of new information on the basis of inference, provided the base on which I'm basing that inference is legitimate. So what hangs on whether we accept this principle, this idea that if you gather some information legitimately, provided you don't do anything, if you don't gather any further information by inquiring and gathering new evidence, gathering new information, you just make inferences on the base, you just make deductive inferences on the basis of the information you have, or potentially inductive inferences, then you're entitled to the new knowledge that you've acquired. So if we reject the principle, then we face what you might call like a cognitive liberty objection, and this applies to corporations, research teams, individuals, which says it seems like it means that even if you have only done your due diligence and you have a bunch of information, there still may be ways in which you are not free kind of morally to just operate your own mind on these things. You can't do research on certain topics, maybe. You can't pursue certain lines of inquiry because there's this risk that even though you gather this information legitimately from customers, from whatever, you might do something wrong and end up with something. And so this seems to kind of impose a kind of constraint on our own cognition that seems kind of unappealing. On the other hand, if we accept the principle, then we have to sign off on some privacy undermining inferences. And sorry, I didn't time that right. So the example I'll give here, which I hate using this example because I feel like I've heard 20 different versions of it, but is everyone familiar with the apocryphal Target pregnancy case? We're all familiar with this, right? So, okay, I only use this example because everyone has heard some version of it. And it's simple enough to make. So the supposed example was Target had gathered some customer information, started being able to predict when people were pregnant in like their second trimester, and then would market information to them about like baby related stuff. And supposedly what happened is a young woman was pregnant, living with her parents. Target sends her all these baby related ads, like flyers or coupons or whatever. The dad finds out, I think was like, really religious in one of the versions of this tellings, and flipped out and went to Target and yelled at everybody. And so basically Target outed this young woman as pregnant to her less than accepting parents. Now there's three things you might think are, so let's imagine this is all true. Something like this could definitely happen. Let's imagine, there's three things that you might think are wrong here. One is by their practices, they disclosed this information about this person, this young woman, to people she didn't kind of decide to disclose to. The second thing you might think is wrong is they took advantage, because there's this research, I guess, that shows that, new mothers are particularly susceptible to like buying at if they start buying things from a particular store, they will continue buying there because it's tiring. You've got kids, and like if you start buying diapers at Target, you'll probably start doing other shopping at Target because it's a one-stop shop. And so it's very profitable to be able to capture people at this kind of vulnerable point. And so you might think there's something wrong about that. But then a lot of people seem to think Target just like shouldn't know that. Like they shouldn't have figured that out. And it's a bit hard to figure it. I mean, this is related a bit to my dissertation. It's a bit difficult to figure out how to explain what it is that we're mad about when we say, I just don't want you to know that. I'm not necessarily, like sometimes clearly we're worried about being taken advantage of or whatever, being manipulated. Other times, I just have this like brute sense that I don't want you to know certain things about me. And maybe this is that kind of thing. Okay. So I want to reject the inference principle because I don't like these kinds of targeted cases or whatever real versions of them exist. But I'm not really sure how to defend it. And so there's this famous defense of it, or not famous, thankfully, because it's not very good, but which says, okay, so here's a defense of the inference principle. Or I'm sorry, a defense of, here's an argument against it, an objection to the inference principle. So someone who's attempting to do what I would like to do, but in a very bad way. Let A and B be two legitimately acquired pieces of information about some subject. You may only infer C, inductively, deductively, whatever, from A and B if S intentionally waived a right to privacy with respect to that further inference. So if you get A and B legitimately, and you can, as a matter of like epistemic ability, you have the inferential tools to make an inference to C, you can only do that if the subject waived their right intentionally to that piece of information. Now, there's like a gazillion things wrong with this. I'm not going to go through them. First of all, intentionally, unsurprisingly, philosophers have a lot to say about what does this mean. We seem to all the time be sort of protected from things over which we are not constantly exerting like very explicit intentional control. What do we mean by a waiver? Also, it seems like this would require something cognitively and epistemically completely unreasonable of agents, which is I would have to know everything that you could possibly infer from whatever I've given you, and then assess which things I sort of care about. And one of the things that it seems like machine learning type research in AI has shown us is that like people can learn things about us that we never even knew were facts about us, or kind of we're never cognizing in a particular kind of way. So let me just make sure I'm doing things here in this. Sorry, this is all a little scatterbrained because of this morning. Okay. So I would like to figure out a way to constrain this principle so that we can say, look, Target, I mean, let's assume you think Target should not have figured out that this person was pregnant, even though they had like, I think it was like supposedly, you know, buying like switching to unscented lotion combined with some other stuff meant that with some really high likelihood people were pregnant. Okay, so let's say so fine, you consent to giving away what you've purchased, but you just think like Target shouldn't know this piece of information. So, okay, what's a principle that explains why they shouldn't know? Is the principle corporations shouldn't know about pregnancies? Well, like that's ridiculous because that's going to depend on all sorts of things. And so, you know, there's this attempt to say that, well, maybe the reason it was wrong is because the subject, the pregnant woman, she didn't intentionally give Target permission, whatever that means exactly, explicit permission, she didn't intentionally give permission to get to this information. So, my bad. Okay, so here's 5 and 6 is a combination. 5 different things that you might think would be a starting point for trying to come up with a better constraint. So zetetic, that's just a philosopher annoying term, and I tried to think of a better word that was less words, but I didn't. Zetetic just means sort of inquiry-directed goals, so goals about finding out things, as opposed to practical goals. So you might think, well, we could come up with some constraint that says, okay, if you legitimately gather information, you still are not allowed to try to infer things that would sort of answer certain kind of inappropriate questions, and we might in advance be able to specify some kinds of questions that we think are sort of inappropriate. 5 minutes left? Beautiful. So that's, maybe good, but part of the problem there, again, is there's things that I don't know yet that I don't want you to know, or a state, or a company, or whatever. And so this seems to put unreasonable demand. If it's anything that the agent, that we sort of, it requires that not just the agent, but us as like researchers and scholars and people trying to figure out what these principles are as a society, as a group that is smarter than any of our individual component people, still it's going to be quite a lot to come up with a constraint like that. You might say there's practical constraints. So Target was, presumably marketing this stuff, found out that it made this inference, came to know this thing because they wanted to use it for certain kinds of purposes. And maybe certain kinds of purposes are not legitimate in certain contexts. You might think, clearly you should be able to opt into marketing about pregnancy materials if you like that, if you want that. But maybe we could come up with something. We could come up with some kind of more precise in that vein. You might think, number 3, there's like just subject matter constraints. So as a matter of fact, the law does treat certain kinds of information, depending where you are, as just sort of like special and sensitive, health information, whatever. Revenge porn laws protect certain kinds of information, essentially, against sort of what is normally a default preference towards privileging free speech over privacy concerns. Revenge porn is an exception that has kind of to do with the nature of the information that is often being shared. But we all know there's like way more things than just like sexual and health information that we might care about. Financial information, whatever. Even all these kind of big ones that people talk about, there's other things. So that's going to be tricky. Agential constraints, so you might think there's maybe something like, maybe it's okay, maybe no individual human can do anything wrong by sort of just operating their own mind on some collected information, but somehow corporations are different because they use machine learning, and that kind of gives them unfair inferential power that ordinary people don't expect one another as human agents to have. This is going to run into lots of problems because, well, what if I'm not an engineer. What if I'm like one of you and I make some great algorithm at home that allows me to, gather legitimate data sets from the internet and then infer all sorts of things about people? Is that better just because I'm an individual that has paired myself with an algorithm? Is there something about the collective structure of corporate or state entities? It's just going to be tricky to figure out exactly what the distinction is between the kinds of agents that we care about having certain information or inferential permissions and which ones we don't. So that's gonna be tricky. And then finally, you might think maybe there's some way of specifying, like, again, maybe we think that AI is just sort of an unfair, like certain kinds of machine learning provide like unfair inferential power. And at least until we adapt as a society to having a sense of basic broad expectations about what each other's capabilities are, now that we are augmented as individuals with not just smartphones, but these kinds of algorithms and things, maybe at some point you could say, well, you know, it's not okay to make inferences off of legitimately collected data if you're, you know, they're like statistical inferences in a certain kind of way, and they rely on data from many, many people to make inferences about individuals. Again, there's tons of problems here. The last slide is just to say, basically, I think these problems fall, the kind of broad bucket challenges is there's like these, I've mainly been talking about theoretical worries, which is like, how are we gonna even articulate a principle of what kinds of inferences are legitimate to make on the basis of legitimately collected information? Because a lot of people have the intuition you can breach people's privacy by making inferences off of information they in fact did give you. So if we think that, I mean, maybe just deny that, just accept the inference principle. It's just, I'm not really sure exactly how to come up with a clear, non-arbitrary principle. And then there's like the technical, practical worries, which is how, and this is something I know less about, but how could we design an algorithm kind of in advance, perfect, that would sort of have these guardrails that didn't nevertheless require unreasonable demands on us about knowing what in fact, because we learn things all the time through machine learning that we didn't seek out specifically to learn. We discover things. So we can't design constraints with those discoveries in mind since we don't know them yet prior to inference. And then finally, I think there's a lot of legal worries about how we can sort of after the fact regulate this stuff. I'm sorry that ran longer than I was hoping to have more time for questions, but that's everything.
Thank you so much. Thank you so much. We're not going to have time for questions, but you can ask Cameron and Lisa also, who didn't get to ask questions during our break. We're going to have a break until 3:20. We're going to try to start a little bit before the last keynote and last panel discussion to announce Best Student Award lightning presentation. Okay? Thank you.